Hello and welcome back to the fourth series of OpenCL C++ step-by-step API tutorial. Today we are gonna talk about how to write our actual kernels. In the last three videos we managed to work with the C++ API to know which platform and devices are available on our platform, compile a kernel for that specific device that we have and run that kernel. So now that we have the power of running kernels, it will be cool if you understand how to write the actual kernel in the OpenCL. As we've talked before, OpenCL is a superset of C99, so if you're familiar with the C coding and C language, you will have little hard time to grasp the concepts and apply it here. There are some so we basically gonna code like C, and there are some extra functions and keywords that we are gonna learn so that we are good to go with our OpenCL programs. So let's start from where we left off in the last session. If you recall, we managed to run our kernel, and those hello words are what our kernel is printing, and today we are gonna talk about that and change that, and we are basically gonna give it simple inputs and outputs. And there's this thing that I have to tell you: we cannot cover all the ins and outs of the OpenCL, and we do not intend to do that, but we will give you enough material so that you can grasp the concepts and apply it to your magical problems and solve it with your problem solving power. And we will teach you the basics, and that's all. So for those who are new, we managed to find our platform and devices. We managed to in our first session. In the second, we managed to actually compile that program for our device and build the kernel out of that, and in the last we run the kernel. Now let's see what the kernel is and how we can make it more beautiful. So if you recall, this is the kernel yeah, this is the kernel we managed to run, and these are the hello words that you print, that is printed. If you look at it, it's just a C program with just with an extra function and an extra keyword. So if we omit the kernel and if we omit this function, it's basically avoid printing C function. So you see that if you know how to code in C99, everything seems familiar here. So what are these keywords and how we can find more keywords, what keywords are available, and where we're gonna use them. Okay. In the second video, I showed you that if you don't put the kernel keyword here, the OpenCL doesn't understand that this is the entry point for your kernel and doesn't recognize that you compile it. So we basically know what's that and why we're putting there. But what is this? What is the get global ID? So let's take a deeper look at what OpenCL is, and I'm speaking specifically in terms of GPUs, but you must know that OpenCL just works for any kind of processors array. So let's just let me open the paint for a second and show you something. Let's say that for sake of simplicity, this is the layout of let me line. Yes, this is the layout of my GPU, and each square or rectangle, whatever, is a tiny processor that I'm gonna use to run my code in parallel. Okay, so this is the CPU or processor number 1, number 2, number 3, and so forth. And I guess for a normal GPU that we have today, we can expect around 1000 processor units. So let's name it in an array shape. I can call this 0. I'm sorry. I can call this 0. Let me second this. Haven't used paint so much. So yes, let's call this 0. Let's call this 1. Let's call this 2, and so forth. See? So this will be 3. Let me continue a little bit. and then 5 and 6, and you know how it's going. So if we manage to name them something like this, it's basically we've given them a unique identifier, a unique global ID that we can call them, and based on that, so whenever I call that, hey, I want to processor 0 to do something, we know what's processor, where processor 0 is, and what's gonna do. So this is basically giving and assigning each processor a global ID. Now imagine that uh, our is our real architecture of uh, processor is a 3D dimension, in 3D dimension. So this is something like 2 dimension. For example, what I mean is I can give you 0, 1, 2, 3, 4, but there is another dimension here, so I can at the same time give it 0. For example, 0, and this is 0, 1, and this is 0, 2, and so on, and this is 1, 0. You know, this is 1, 1, and this is, for example, 2, 0. So go on. So it's a 2D dimension assigning. It's just assigning a number to some processors, nothing else. And we can apply to a 3D. So this will be 1, 0, 0, 0. This will be 1, 0, 1, 0. The beyond dimension that I can show you is, for example, 1, 0, 0, and go on. So basically, we have, say, 1000 processors. We can lay them out, as I've told you in the previous video, with this parameter here, ND-range. If you recall, ND-range could accept arguments up to 3. See? 1, 2, 3. So I have 1000 CPU. Think of them as liquids, as something you can shape them. Okay, so I can shape them in 1D array, I can shape them in 2D array, or I can shape them in 3D array. And when I shape them, if it's 1D array, we can put 0, 1, 2, 3 for the global names. If it's 2D array, it's 0, 0, 0, 1, 1, 0, you know. And if 3D, it's 1, 0, 1, 1, 0, 0, 0, 1, 0, and so on. So you know what I'm talking about. So what get global ID is basically is a function that OpenCL adds for me to get the number that we just assigned to our processor. So in our example, I'm using a 1D array of 5 processors. Out of 1000 processors, I'm just going to use 5. I don't need more. So the global IDs are 0, 1, 2, 3, and 4 in a 1D array. So when I just get the global ID, and I'm talking about this 0 in a minute, I'm getting this number, that which processor this code is running into. Now, this is the thing. When we upload a kernel onto the OpenCL device to run, each processor just accepts the same kernel. It's up to me, the programmer, to differentiate between them, to tell them do different things. And how do I do that? With the get global ID. You know, if I say if you're 0, do this. If you're 1, do this. If you're 2, do this. This is one way. Or say that we are processing an image. You know, each one of these processor just maps to a pixel. So I know the pixel, and I map the global ID of my processor to the number of pixel, and each processor does a processing of a pixel, and we go on. So here I get the global ID, and because I'm one dimensional, you see, I'm using here a 0. So I get 0, 1, 2, 3, 4, 5. Now, in the last video, I told you that why, if you pay close attention, 1, 2, 3, and 4 hello worlds are printed. Now you know why. Let's have a look at this. You know, here I said that if my global ID is greater than 0, and as we have 0, 1, 2, 3, 4, only 4 of them, you know, is greater than 0. So let's change this now that we have, and say that I want to only this first processor, the number 0 prints hello world, and others don't. You see? And if I do that, simply, you see that there's only one hello world here. So yeah, and you are already richer in your knowledge about OpenCL. So let's go forward. So what if I want to arrange in 2Ds? Simple as that. You see, I told you that ND range gives you the power to architecture your processors. So I want a 5 2D array. Let's run it again. See what happens. Oh, I got 5. What happened? Can anybody say what happened at 1, 2, 3, 4, 5? As soon as I did the 2D things, then 4 other processor printed hello world. What happened? Could you guess? So yes, I guess some of you could guess what happens. If you don't, just stay with me. So now I have 2D processors. See, I have 5 here. Good. So let's name them in 2D dimensions. Okay, let's name them. It's 0, 0. It's 0, 1. It's 1, 0, for example. It's 0, 2. It's 0, 3. It's 0, 4, and so on. 1, 1, for example. 2, 2. 3, 3, 4, 4, and you know what's happening there. So it's basically 1, 2. It's basically 2, 1. So if you recall, see, all these processors here, these little beautiful processors here have 0 for their first global ID. See? So now you know what. As here, we just tell this that get global ID of 0, which means first dimension. Now all the processor with the first dimension equal to 0, which are 5 in our 5v5 array, are printing hello world. So if I wanna give it a 2D representation, what I'm gonna do? Basically, get global ID accepts an input, and that input is an integer showing the dimension. 0 is x, for example. 1 is the second dimension, as 2 is the third dimension. So basically, I'm gonna tell this that if my first dimension is 0 and let's say my second dimension with 1, oh, I'm sorry, what's this opening? 1 equals to, for example, 2. I want this little processor around here to print things. And now let's run our program and see what happens. See, it's again 1. So now you know what to do. Now you know that with power of ND range and with power of get global ID and identifying the dimension you want, you can tell which processor exactly what you want to do. Isn't that beautiful? So for now we know what global ID is. Now what if I wanna tell from the outside world, for example. Now we wanna just do a simple input output thing. So I'm gonna give it a number as input. Okay, we can use that number for the number of processor to do things, or we can print that. Maybe I'm fine with just printing this. So it's C. Yeah, how do you give C an input? For example, this. Huh? Ain't that simple for you? That you are familiar with C? See, OpenCL is nothing for you. So we're good to go. What we lack here, okay, is we haven't provided temp yet. Let's run it for a minute and see what happens. I guess we ran into error. Yeah, no, it does not run into error. Okay. I was wondering. Oh, I haven't saved this. I was wondering what will happen. Oh yeah, it doesn't run. It must be a core dump or something. Okay. So you see that when we do this and we don't provide argument, it doesn't run. So what we're gonna do? Do you recall the last video, the third video, when I told you that the template type of the function is actually for the inputs and outputs you're gonna have with your kernel, for you to talk with your kernel? So here's what we're gonna do. We're gonna add our input here. So the functor is our function really. So I want to give my function an input. I have to give my functor an input. You see? And if you recall, and if you don't go back and watch it again, I told you that arguments showing up here will be add to this. So if I put something here, I will put that here too. See? That's simple. So now I want to give an int. So am I okay to write an int here, for example? Oh no, I'm not. There is some PDF that you should have with you if you want to write OpenCL, and will come in handy, and that's the OpenCL specification I use for version 1.2. And in this, we can fall on the functions that we have talked about. So, for example, let's find our global ID and see what it says about it. It will be fun. See, where did I found the get global ID? I didn't. It didn't come from out of the blue. You know, I read this. So if you want to know what other functions we have, here it is. I told you that I give you the basics and the tools you need to grasp the concepts. So here it is. You see, just with a little search in this long documentation, you can find what functions we have, what types we have, what keywords we have, and really easily we can find what get global ID is. For example, it returns the unique global work item ID value for dimension identified by dimension index, you know, and the rest. So basically what we told. And I wanted to give you more context. See, we have a local ID too. Not we have the global ID, we have a local ID too. So what's the difference between the local ID and a global ID? So these are the things that you must be curious of, and it's somewhat of homework for you to go and find out. We'll talk about it later. Or other dimension, we can get the size, we can get the dimension, you know. For example, we get work the dimension, we can get how many dimensions we identified here in the range. Let's try it out. Let's try it out. Let's for 1 second forget about this, and we want to get work dimension. The return type is an integer. So let's say that int of temp is equal to get work dimension. And how many dimension did we specify? 2. So already we know what the answer must be. Let's see if it's true or not. Oh, I think I didn't save it again. Sorry. See, there's 2. So basically you know what to do with these little tables and functions. You can get groups, you can read what groups are and everything. Now I want to talk about the types. So if I'm gonna just search types and see what I find here. See the supported data types 197. If I just fast forward to that page, you see, these are the supported types of OpenCL. They are pretty much similar to us programmers. And how I'm gonna write them down, just come down and yeah, here it is. API, you know, the API type for application. That's what we want. So if I'm gonna use an integer, CL int, you know, just a CL underline that is prepended to the type name. So you see, it's really easy. Just you know how you should get familiar with this documentation and know your way to how to search and find what you want. So I want CL int for the API type. But there's something. See, there is in this table we have a type in OpenCL language, which are basically the types we all know. So for example, if I'm writing OpenCL and I want to give the function an input, I just type int, I choose the left side of this table. But when I'm gonna match that with the type in our API, just bear with me, that is CL underline prepend to it. So it's CLint. This is the difference. So here I will use CLint. You see, this is the difference that you should know. So now that I have identified the CLints here, see the functor says I need more things. I need more args. See, an integer is added here, so I can give it 5, and everything is good. See, so let's save it and run it and see what happens. Tada! We are OpenCL masters, aren't we? So we just gave the OpenCL an input and we basically printed that. I hope you enjoyed this tutorial. Stay tuned for more.